Math is not happening. And we'll get to why and how my math is not happening in a moment. Can you help me with the bell ringers? That would not be the bell ringer. What's the first thing I should do on our first bell ringer problem? I did the same thing first period, and that's actually that's a better idea because I tried to distribute too, and I'm making life too complicated, just like I'm making life too complicated getting this bell ringer off this slide. Whew. Life too complicated. If I were to combine like terms, I would have negative 1.7, negative 6r plus 6.6 equals 15.3. Now what? Okay, let's distribute that negative 1.7. I need to know negative 1.7 times negative 6. Say it. Thank you. And then negative 1.7 times 6.6. Okay, now what? Okay, so if I add the 11.22 to both sides, I'm out of room, so I'm going to put a star and go up to the top. I would have 10.2 equal 10.2r equals what number? Now, you and third both said 50.52. For some reason, first and second said 26.53. I don't know where that number's coming from. Someone will have to explain that to me later. Now, what? How do I solve for r? Okay, if I divide both sides by 10.2, I get r equals some number.
R equals 2.6.
Perfect. Were there a lot of steps required? Yes. Did we talk about multi-step equations first semester? Yes, we did. Are there any questions on that first question?
No, ma'am.
Then on the second bell ringer, what should we do first?
Oh, distribute.
Okay, if I distribute, I would have 10/6. No, that's not right. 10/3? Yes. In the numerators. No. Plus 5/3 x. Can you? Yes. Am I going to do that? No. 4/5 x plus 4/10. What does 4/10 reduce to? Okay, so I'm going to mark that out and change it to 2/5. Okay, so I have a fraction with a 3 in the bottom, a fraction with a 3, a fraction with a 5, a fraction with a 5. What should I pick for my denominator then? 15, because that's the number that 3 and 5 both go into. So I know I'm going to have all 15s. 3 times 5 is 15, so 10 times 5 is 50. 3 times 5 is 15, 5 times 5, 25. 5 times 3 is 15, 4 times 3, 12. 5 times 3, 15, 2 times 3, 6. So I have a 50 over 15, a 25 over 15, a 12 over 15, and a 6 over 15. Now what should I do? What would you like to do first? SMT, you're on my nerves. So I get, and I'm out of room again. Did not leave enough room for all this. I have 15 equals 15 plus 13 over 15x equals It's 50 over 15, isn't it? I'm telling you, when math mistake, the rest of your math for the rest of the day just goes downhill. It should say 50 over 15 plus 13 over 15x equals 6 over 15 is what it should say. What should I do after that besides apparently go home and cry? Okay, if I subtract 50 from both sides, then I'm definitely out of room to show that. What's 6 minus 50? Okay. Now, how do I get x by itself? I don't want to do that. Why do I want to multiply by? Okay, that's what I would rather hear. So those cancel out, and I'm really excited on the right-hand side. Why am I really excited? Why am I really excited on the right-hand side? Because the 15s cancel out.
Yeah.
So I get negative 44 over 13. Could you change it to decimals and still probably pick the right standardized test question answer? Yes, you could. Stop being a silly goose, though. Fractions are a friend. And then someone in a different class period kept trying to write mixed last period, like 5/3 is 1 and 2/3 or whatever. We don't really do mixed numbers anymore. We leave it as improper fractions. We're good with that. Good to go with that. Are there any questions about the bell ringer?
No.
Okay, well, I'm done talking about quadratics. What's to do tomorrow? Okay, so I said I'm done talking about quadratics, and I'm still going to have to reference them today. So far we've talked about, a lot about linear functions. And then recently we were on a kick about quadratic functions, and today we're going to learn about a third type of functions, and there are many, many more. We're going to talk about a square root function. It looks exactly like it sounds. Instead of being y equals x, which is linear, or y equals x squared, which is quadratic, a square root of function is y equals square root of x. Okay, we don't even know what it looks like yet. We haven't even talked about that. But we see that it has a base form. It reminds me of the vertex form with quadratics because the h and the k when we were looking at vertex form with quadratics, and we had to determine the vertex from here, what do we have to do with the h? Yeah, it's the opposite sign because of that minus. So if it's a minus 3 here, it's a positive 3 here. That's still going to happen. In fact, that HK form we even talked about with an LTF lesson with linear functions. You can see any parent function will have h and k. That's like a specific vertex point. Okay. Goodness. And what was the A for? What was the A for? On a quadratic function, what did the A decide? Why were we happy when A was 1? Because it was squares, and we did over 1 up 1 over 2 up 4 over 3 up 9. When it was a half, what happened with a fraction on a quadratic? Fractions made you fat, and if it's a whole number, it made you skinny. So that A is going to change our graph, either make us fatter or skinnier, or maybe look normal. But again, we still don't know what the graph looks like, so we need to talk about that. Okay, remind me, and this was a few weeks ago when we were in Mr. Furman's room. We had a whole discussion about these two graphs. What's the one on the left called? And it has a name, a parabola. What's wrong with the one on the right? Why is it not a function? It doesn't pass that vertical line test. But what if I were to erase part of it? What if we only looked at that top part? Would that be a function, just that brown part? In fact, that is what a square root function looks like. A square root function looks like an arm. Just the top. So it's a parabola on its side, but only half, because the bottom half wouldn't pass the vertical line test. And then if we're thinking math-wise, the reason there is no bottom half is because that would be for the negatives. We don't do the square root of -4. We only know the square root of +4. We don't know the square root of -9. We only know the square root of +9. Okay, so saying all that, all the graphs we're going to do, the parent function, let's go ahead and do that. So I'm going to, here's my coordinate plane. The first one we should graph is the parent function. Where is the vertex of this parent function? Yes, the h and the k are 0, 0. Any good parent function's gotta have a vertex at the origin. Okay, how are we counting? What is the a in this problem? It's 1. How are we counting with quadratics when the a was 1? Okay, well here we're going to count by square root. So like the square root of 1 is 1. The square root of 4, 1, 2, 3, 4, is 2. And if I had room, the square root of 9 is 3. And if we wanted to, the way we used to plug in points, we could plug in points for this. It's going to end up being the points I'm saying. We would want to pick pretty perfect squares. So for instance, if we plugged in 1, we would get square root of 1. Well, that's just 1. So we for sure have a point at 1, 1. Let's say we wanted to plug in a 4. Well, that would be square root of 4. Well, that's 2. That's why we have the point at 4, 2. So these points that I'm plotting, I'm not just making up. I'm getting them from the square roots. So really what we would like to do is have a pretty perfect square underneath that radical. If I had room, I would go over 9 up 3, over 16 up 4. And what we got into a discussion about last period, which is how we got a little tongue-tied, but it's okay, is that it ends up being instead of being, it's like, hold on, I'll let you do that and I'll say my words. If we were to turn a paper like this, then really I'm still doing our normal counting method, the over 1 up 1, over 2 up 4, and if I had room, over 3 up 9. If we were to turn it back to normal like we like it, to make it look like a quadratic rather than a square root, that would work. Now most common, why are those two so related? And that's because they go hand in hand. 3 squared is 9. The square root of 9 is 3. Those numbers go together. 4 squared is 16. The square root of 16 is 4. Those numbers go together. So quadratics and square roots, they kind of undo each other when we work math problems. So no wonder their graphs look similar. Okay. We're going to work a couple problems, and then I'm going to give you an assignment. It's really short and easy. You want it to be in this form. If you're given an equation not in this form, you should, let's say like the k was over here, you should move it. You want it to be in this base form. Okay, so our first example, let's do y equals the square root of x minus 3 minus 4. Can you tell me where the vertex would be for that parabola? Positive 3, negative 4 is correct. Are there any questions about that? So if we go over to positive 3, negative 4, 1, 2, 3, 1, 2, 3, 4, I put my point. It would be nice, just like with quadratic functions and parabolas, you know how on the board I said it would be nice to have 3 points? It would be nice to have 3 points on this graph, but I don't think we have enough room. Okay, I know the square root of 1 is 1. I know the square root of 4 is 2. So I'm pretty sure those are my next 2 points. Pretty sure. But the reason I could count like that is because what is my A? 1. But if I'm being smart and I'm thinking this through, if I go back to my function and I think through what numbers to plug into it, what would be a good number to plug in for x so it will be a perfect square under that radical? 4 would be a good one. I like that one. Now, why 4? What's 4 minus 3?
1.
What's the square root of 1? So I really have 1 minus 4. What is 1 minus 4? Negative 3. So I know there is a point at 4, negative 3. So if I look at my graph, 1, 2, 3, 4, negative 1, negative 2, negative 3, lo and behold, that's where I put my second point anyway. What would be another good number to plug in? Well, I don't want to plug in 9 because 9 minus 3 is 6, but you're on the right. You're in my ballpark. Say it again. 12 would be great because you get 9 minus. I agree, but it's not going to be on our graph. I was hoping there was another one on the graph.
I'm confused.
Yeah.
Okay, so where did you get 4, negative 3 from? Like, I get that you did 4 minus 3 and 1.
I plugged in a 4 for the x.
Just because, like, you just...
I got out a negative 3 for the y. So I know my point's at 4, negative 3. Why did I pick 4? Because I wanted a perfect square under that house. Which is why Zach suggested plugging in a 12. Because 12 minus 3 would be 9. And you would have a square root of 9. So we're trying to think of a number to plug under here so it'll end up being a perfect square under the house. We plugged in 39. 39 minus 3 would be 36. Square root of 36 is great. I'm thinking real low. Real low. Why don't I just tell you what I'm thinking? What if we plug in a 7? Why is a 7 a good number to pick? 7 minus 3 is 4. What's the square root of 4? What's 2 minus 4? So I have a point at 7, negative 2. And why did I pick that one specifically? Because I almost have that one on my graph. 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2. That's the one that I almost have right here. Although Cruzen and Zach make very good suggestions, and theirs just aren't going to fit on this specific coordinate plane. Okay, are there any questions about that? Again, I plotted those 2 points before I even calculated this. Do I have to calculate this if the A is 1? Probably not. So let's do another one nice like that, and we won't calculate anything. For our second example, we'll do y equals square root of x plus 2 minus 3. So where would my vertex be if this was my parabola? Parabola, good grief, Miss Compton. If this was my square root function, where would my vertex be? -2, -3. The opposite sign for the x. Are there any questions on where we're getting that vertex from? Okay, so if I go to -2, -3, I put my point. I know the square root of 1 is 1. I know the square root of 1, 2, 3, 4 is 2. So because my A is 1, I can graph it like that, and I've got my 3 points, and I'm done. But if Zach wants to, could he think through numbers to plug in here? Yes. For instance, if he plugged in a -1, he would have 2 minus 1. So it would be the square root of 1. So it would be 1 minus 3. Well, 1 minus 3 is -2. And that's where we put our point, -1, -2. Or if we plug in a -2, -2 plus 2 is 0. The square root of 0 is 0. So we get 0, -3. Hey, we put our point at -3. Or at -2, -3. That came out all weird. Okay, are there any questions with the easy ones?
Easy ones.
Yeah, the easy ones. No. No. Are there any questions with those?
No.
Then we're going to complicate our life a bit, because you get that Miss Compton was making it a little... He's right. I am making it a little harder than I have to, just so these don't seem as ridiculous. So if I do 1/2 square root of x, and I'll do the same vertex, x plus 2 minus 3. So I'm still going to have my vertex at -2, -3. So my third example is still going to start off at this point. Why can I not? Why is it not the exact same graph? Because of the 1/2. We've changed the A. We've changed that A. And this is where we ran into an issue last period. So I got my vertex point, and it's come that I need 2 more points on that graph. So we started debating, like, could we count it? Could we figure out an easy way to make this go? So we discussed that this number was like a slope. So maybe it would be up 1 over 2. But then that's about where I started questioning my sanity. So if you don't want to plot that point, I understand. 'Cause that's about where Miss Compton started questioning her own sanity.
How about up to over 1?
And then I'm like, which one is it? Is it up 1 over 2? Is it up 2 over 1? I think it's up 1 over 2, the way we normally count slope. Then I start questioning my life, which is how we ended up in the debate that Cruson and Zach were already participating in. What are some good numbers I could plug in to my function to figure out 2 more points anyway? What if I want to calculate things? I want 2 more points. Tell me a good number to plug in my function.
What about 3?
3 plus 2 is 5. We don't want square root of 5.
4.
4 plus 2 is 6. We don't want square root of 6. We got to think perfect squares. 6 plus 2 is 8. We don't want square root of 8. 2 plus 2 is 4. We'll take that. So we're thinking through strategically what number to plug in for x. Because if we plug in a pretty perfect square number, and we make this radical a perfect square, or not a perfect square number, but if we make this radical a perfect square, we can end up having a nice pretty point. So I have 1/2. What is the square root of 4? Okay, what is 1/2 times 2?
1,
So I have 1 minus 3. What's 1 minus 3?
2.
Okay, so my point is really at 2, negative 2. So I know there was a point at 2, negative 2. So I was already wrong. So we can ignore that one. Ignore me. Okay, what would be another good point, another good number to plug into this function? Why would 7 be a good one? Square root of 9, perfect. I don't want to do that. I want to go a different way. Can you go backwards for me?
1,
1 plus 2 is 3.
0.
0 plus 2 is 2.
What do you want to get to? I'm saying you want to get to 1.
We're wanting these two numbers to add together and give me a perfect square. So whatever number you say, add 2, is it a perfect square?
Okay. Negative 1.
Negative 1 is a good one, because then I would have 2 minus 1, which is just 1. So square root of 1 is just 1, so I end up having 1/2 minus 3. What's 1/2 minus 3?
1/2 minus 3 is negative 2.
Okay, so negative 2.5. So I need to go to negative 1 and negative 2.5. Okay, flip your paper over. I need to do one more for my own sanity. Where would the vertex of this one be? Okay, so I go over 4, I go up 2, we're just going to pretend it's there. Looks good. Real good. Awesome. Now I just count over 1 up 1, over 4 up 2. I can't do that because why?
A is 3.
Because A is 3. Darn A being 3. So the easiest thing to do is think through perfect squares under this. So what? I need at least 2 more points to make this one a good one. What's a good number I could plug in?
3.
Why would 3 not be a good number to plug in? If you plugged in negative 1, you'd have negative 5 under the radical. I need a number to plug in.
So 5.
5 would be a good one. Why is 5 a good one? Because 5 minus 4 is just 1.
I like it.
So I have 3 plus 2, which is just 5. So I have a point at 5, 5, unless I've done my math wrong. Which I don't believe I have. But it's been that kind of a day. So if I had room, we already had a point at 4, 2. I would go over 1 more and uppercut a little more and say that's 5, 5. And then we're going to need at least 1 more point for Miss Compton to be satisfied. What is another number we could plug in to make this a pretty perfect square under the radical? 18 would work because 18 minus 4 would be 16. And that's a good one, but that's a really big one. So his suggestion was 8 because 8 minus 4. 8 minus 4 is just 4. I know the square root of 4 is just 2. So I have a point at 8. Unless Ms. Compton, again, has done her math wrong, which I'm telling you, is very, very possible today.
Wait, you get the square root and then you add 3? Wait.
You picked 8. I did 8 minus 4, I got 4. I know the square root of 4 is 2. I did 3 times 2, I got 6. I did 6 plus 2, I got 8. I told you it wasn't that hard. It's not hard at all when A is 1. It should be easy when A is being a 3 or 1/3, but I swear I'm overthinking my life today. And when you overthink things, should you plug things in and calculate your own coordinate point? Of course. My God, please do that. Okay, I'm going to start recording things because I don't need to be on camera anymore.